Hello, welcome students. And in the previous lectures, we have just started discussions of our new topic, that is topic number 14, semiconductor. This topic is the most important in our syllabus. Not only syllabus, this is the most important in our future. This is the most important in our life and whole futures, whole industry, electronic industry will be depends on these topics, that is the semiconductors. In these lectures, we are start to discussions of the electrical conductance in solids. We know that we are described the three different types of the conductance, that is in the defense of the conductance, that is electrical conductors, insulator and semiconductor here. Then we are discuss one by one and take the heading of electrical conductance in a solid. We are classified the solids in three different types according to their conductance, that is conductors, they are all metals, insulator and semiconductors. Let's taking the heading electrical conductance in solids. The electrical conductance, it takes place in a solid by or due to transformations or transfer of the charges. In the previous lectures, we are discussed when the improving the temperature, increasing the temperature, the negative charges will be travels from the valence band to the conduction band. This is conductions or the electrical conductance in the solid. It takes place by the transfer of the electrical charges. And this is the taking a point. It is takes place in solid by the transport of charges. It may be negative charges, that is electrons or holes. It can be transferred. It is due to the transformations of the charges. Then let's start to discussions of the one by one types. That is the first types is conductors. The type number A or type A, that is conductors. And the conductors is also metals. All metals are good conductors. The best examples of the conductors is any metals. The best example of conductors are taking any metals. Any metals are the good conductors, are best conductors. The large number of free electrons will be present available in the conduction band in the form of conduction. This is the main reason for the metals are good conductors. Why they are good conductors? The large number of electrons, I will be write the NO for a short form of number. The large number of electron, that is E, present or available in conduction. The amount of electrons which can be available in the conduction band of the conductors is 10 raised to 28 electrons. 10 raised to 28 electrons present, or it is another point, that is 10 raised to 23. It gives us in a different books. 10 raised to 23 electrons present in per meter cube. एका छोट्याशा युनिट डिस्टन्स असले छोटासा एक सिंपल क्यूब जर घेतला तर त्या सिंपल क्यूब मध्ये 10⁻23 इलेक्ट्रॉन्स विल बी अवेलेबल फॉर द कंडक्शन्स और फॉर द कॅरिंग. दिस इज द एक्झाम्पल्स ऑफ द कंडक्टर्स. द मेटल्स विल बी गुड एक्झाम्पल्स ऑफ द कंडक्टर्स. Then these conductors is happen, the metals are good conductors due to the large number of electrons will be present available in the conductions. The next one examples we are taking here, that is second part, that I will be taking here B. The second part B is insulator. Insulator. The insulator is also called as a bad conductors. The glass, wood, some examples are glass, wood are the good examples of insulator. There are some common examples of the insulator. The number of very small amount of electrons will be present in the conduction bands. Very small amount of electrons. Very small amount of electrons. The very small amount of electrons, this will be exactly numbers, that is 28 10 to 28. That is the very small amount of electrons will present or available in conduction bands of that insulators. The number of electrons will be 10 raised to 23 per meter cube. 10 raised to 23 per meter cube. They are the good examples. Very small number of electrons will be present in the conduction band of the insulators. I will be use the one of the most part, third part of the electrical conductance, that is C, semiconductors. Semiconductors. The conductivity of the semiconductors is in between the conductors as well as insulators. Then the examples of, that is silicon, germanium, gallium arsenide, that is gallium arsenide, and some another examples they are used, or also gallium nitrate. These are the examples of the semiconductor. Then the conductivity of the semiconductor, the conductivity of semiconductor, the conductivity of the semiconductor is in between conductor and insulator. The conductivity of the semiconductor, the conductivity range, the conductivity of the conductor is large, the conductivity of the insulator is very small, the conductivity of the semiconductor is in between the conductors and insulators. Okay, why we are use the semiconductor, why we take the semiconductor for the study, for the discussions, or in the physics. Okay, तर ह्याच्या अगोदर 13 टॉपिक्स होते, 13 टॉपिक्स तर कमी होते की सेमीकंडक्टर एक एक्स्ट्रा टॉपिक घेतलेला होता. किंवा आपल्याला जर कंडक्टर्स पाहिजे असेल तर कुठल्याही पद्धतीचा मेटल घेऊ शकतो, दे आर गुड कंडक्टर्स. इन्सुलेटर पाहिजे असेल तर ग्लास, वूड घेतलं असतो. ठीक आहे, चांगल्या पद्धतीने या दोघांचा संसार चाललेला होता. पण सेमीकंडक्टर्स घ्यायची कारण काय, वाय वी आर टेकिंग द सेमीकंडक्टर्स इन एक्झाम्पल्स. ओके, कुठल्याही पद्धतीचं जर डिव्हाइस तयार करायचं असेल तर आपल्याला कंडक्टर पाहिजे असेल तर आपण कुठल्याही पद्धतीचं मेटल यूज करू शकलो असतो. जर इन्सुलेटर पाहिजे असेल तर या पद्धतीचे एक्झाम्पल, दॅट इज ग्लास अँड वूड यूज करू शकलो असतो. वाय वी आर टेकिंग द सेमीकंडक्टर टू फॉर्मिंग अ डिफरंट डिव्हाइसेस, दॅट इज LED televisions, or also some different gadgets, cell phones, electrical watch. Okay, why we are taking the semiconductor? Because the number of charges, number of charge carriers will be controlled. The number of charge carriers will be controlled as per our required. Control as per our requirement. This is the most useful things of why we are using the semiconductor in the lot of gadgets, lot of devices. Because the number of charges carries means it's the indirectly conductivity of the semiconductors are we are controlled. या ठिकाणी देखील आपण कंडक्टिव्हिटी कंट्रोल करू शकतो, but we are lost some energies. We are used some energy to control the conductivity in the metal, but in the semiconductor we don't have any energy, we don't require to any energy to control their conductivity. Then the number of charge carriers will be controlled in the semiconductor as per our requirement. आपल्याला कशा पद्धतीने कंडक्शन पाहिजे असेल, कंडक्टिव्हिटी पाहिजे असेल तशा पद्धतीने आपण कंट्रोल करू शकतो. Then one another uses their structure designed, the structure is also designed as our requirement. The structure, their structure also designed as per our requirement, as per our requirement. This is all about the semiconductors, insulator and conductor. This is the electrical conductance in a solid. These all are solids, and the electrical conductance takes place in a solid due to by the transport of charges. And why we are use the semiconductors, the main things will be discussed in these lectures in here. The number of charge carriers will be controlled indirectly. The conductivity of the semiconductors we are control, and we are designed as our requirement. किती लहान पाहिजे, किती छोटासा चिप पाहिजे, त्या पद्धतीने आपण त्याचं स्ट्रक्चर डिझाइन करू शकतो. त्यामुळे आपण या ठिकाणी सेमीकंडक्टर इज मोस्टली यूज इन द इलेक्ट्रॉनिक डिव्हाइसेस. Then the semiconductors, lot of semiconductors will be given, one of the table will be given in your books. Silver, not a silver, that is a silicon, germanium, and also gallium arsenide, gallium phosphate, gallium sulfate, lot of things, cadmium sulfate, cadmium phosphate. They will be gives some examples of the semiconductors, that is zinc sulfate, cadmium sulfate. So a lot of semiconductors example gives in your books. And in these lectures we are also discuss the graphical representations of the conductivity of the metals and semiconductors. I will be use here the graphic, use these portions of the graph board. This is, I will be, let's discuss, this is the conductivity and this will be temperatures. X-axis the text, the temperature, and y-axis the text, conductivity. In the metal, the conductivity will be decreases when we are increasing the temperatures. If we are increasing the temperature, the conductivity of the metal will be decreased. In the semiconductor devices, in the semiconductor material, this is the conductivity and this is the temperature. It will be increases. The conductivity of the semiconductor, this is a B and this is a for A. The figure A will be present the conductivity and temperature relations of the metals, and the figure B is presents the conductivity and temperature relations of a semiconductors. The semiconductors, in the semiconductors, if we are increasing the temperature, the conductivity is also increases. We are discuss years. Let's start to discuss in the one another parts, the types of these semiconductors, the types of the semiconductor, elemental semiconductor, compound semiconductor, organic semiconductors. We are discuss here. Let's revise what we are discussed in these lectures. Conductors, metals, their main examples. The best examples of the conductors is all metals. The large number of electrons will be available in the conduction bands. For these reasons, the metals are in good conductors. The elements, the electrons will be present 10⁻28 per meter cubes. Then the insulator, the glass and wood are the good examples, are common examples of the in good insulator, the very small amount of electrons will be available in the conduction band. The amount of electrons will be 10 raised to 23 per meter cube. And the last and important things we are discussing here, the semiconductor, silicon, germanium, gallium arsenide, gallium nitrate, gallium arsenide and gallium nitrate. These are mostly useful and most used most common examples of the semiconductor. The conductivity of these semiconductor, the conductivity of the semiconductor is in between the conductor and insulator. And why we are using the semiconductors in the lot of devices? Because the number of charge carriers will be controlled as per our requirement. This is the one reason. And second reason, their structure are also designed per our requirement. And we are used two different types of the graph for the discussions. The relation between the temperature and conductivity. The figure A will be present the difference or the relations of the conductivity and temperature in the metals, and figure B will be represents the relation between the conductivity and temperature in the semiconductors. And now we are start to discussions of the types of semiconductor. This is the not n-type, p-type semiconductor or extrinsic semiconductor, but the example by the examples of the silicon, germanium, gallium arsenide, gallium nitrate, we are classified these types of the examples. Let's start. Okay, let's start to discussions of the examples of the types of the semiconductors. That is first type, that is elemental semiconductor. One was type is elemental semiconductor. Elemental semiconductor, that is in the elemental semiconductor the most useful things for the example, that is silicon and germanium. That is silicon and germanium are the examples of the elemental semiconductors. The next one part is compound semiconductor. Compound semiconductor, you know the meaning of that words, that is compound semiconductor. What is the meaning of compound? Will be combined two or more things. We are combined two or more elements, we will be combined two or more atoms, we will combine two or more things. This is the, and we will be combined two or more semiconductor here, two or more atoms, two or more elements to form a semiconductor. That is, examples of that semiconductor is cadmium sulfate, CdSO4. That is, when we are discussed the chemistry, that is CdMSO4, cadmium sulfate. And one another examples, zinc sulfate. Cadmium sulfate and zinc sulfate are the examples of compound semiconductor. Then third part, that is part C, organic semiconductor. Organic semiconductor. In the organic semiconductor, we use one examples about the organic semiconductor, polyaniline. That is polyaniline. We are going in the chemistry lab, that is in the elemental semiconductors we are just use the silicon and germanium. In the compound semiconductor we are combine the two or more elements or two or more atoms, that is cadmium sulfate is the one of the examples of compound semiconductor, another is a zinc sulfate. Then in the organic semiconductor, that is polyaniline is the one of the examples of organic semiconductor. But the elemental semiconductor and compound semiconductor are widely used. The type A semiconductor and type B semiconductor are widely used in electronic industry. And this is the earlier invest. This is earlier invest of that. Then this will be earlier discovered the organic semiconductor, and this is used the laser applications. This will be used the laser application. The lot of semiconductors having the 4 valency. Due to this, they are formed the 4th type and different types in the periodic tables according to their इलेक्ट्रॉनिक कॉन्फिगरेशन्स. त्यांच्या इलेक्ट्रॉनिक कॉन्फिगरेशनमुळे ते एक नवीन एक 4th टाइप्स तयार केलेले आहेत इन द पेरियडिक टेबलमध्ये. आणि त्यांची जी व्हॅलेन्सी असते सेमीकंडक्टरची व्हॅलेन्सी इज मस्ट बी 4. द व्हॅलेन्सी ऑफ द सेमीकंडक्टर इज 4. दे वांट 4 इलेक्ट्रॉन्स to complete their octets, or they will be reduce, or they will be gives the 4 electrons. तर 4 इलेक्ट्रॉनची व्हॅलेन्सी असल्यामुळे त्यांच्याकडे 4 इलेक्ट्रॉन्स आहेत आणि त्यांना 4 इलेक्ट्रॉनची गरज आहे. तर ते हे काय करत असतात, इट फॉर्म्स द कोव्हॅलेंट बॉन्ड. व्हॉट इज द मिनिंग ऑफ कोव्हॅलेंट बॉन्ड? कोव्हॅलेंट बॉन्ड मीन्स you will be discussed in the chemistry, but we are again discuss here what is the covalent bonds, because they are useful in our physics also. Then covalent band means equal sharing of electrons. When the two atoms will be equal sharing of electrons, they form a bond. This bond is called as a covalent bond. In one bond, एका सिंगल बॉन्ड मध्ये 2 इलेक्ट्रॉन्स असतात. ठीक आहे. तर त्या 2 इलेक्ट्रॉन्स एका या ठिकाणी एक आणि जर्मेनियम अँड सिलिकॉन. जर्मेनियम आणि सिलिकॉनमध्ये एक बॉन्डिंग तयार होत आहे असं कन्सिडर करा. जर्मेनियमची देखील व्हॅलेन्सी 4 आहे आणि याची देखील व्हॅलेन्सी 4च आहे. तर हा एक इलेक्ट्रॉन्स देणार आणि हा एक इलेक्ट्रॉन्स देणार आणि या दोघांमध्ये एक बॉन्ड तयार होते. दिस इज कॉल्ड इक्वल शेअरिंग ऑफ इलेक्ट्रॉन्स. बाय इक्वल शेअरिंग ऑफ इलेक्ट्रॉन्स द मेक्स अ बॉन्ड. This bond is called as a covalent bond. And the different types of the bonds will be here: the ionic bond, metallic bonds, a lot of bonds. But we are discuss the covalent bond because these bond will be formed by our semiconductor materials. Okay, in the next lectures we are discuss the band energy or band theory.